Good morning, ladies and gentlemen, and thank you for joining us at our corporate partner, SAIEE corporate partner Rosatom's webinar on norm management, a chance for further waste minimisation. Before we start, just a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of this webinar will be made available on the SAIEE YouTube channel, SAIEE TV. The recording will also be made available on the SAIEE website under the events drop-down menu, past events and webinars. This page is updated regularly, so you should check back as often as possible for new uploads and subscribe to our YouTube channel. A certificate of attendance will be issued a few days after this webinar. While my webcam is on today, I'll be your host. Unfortunately, our Rosatom team has conflicting engagements, so I'll be standing in for them. Just a background on Rosatom is the world leader in nuclear technologies, and they are constantly acquiring new competencies, providing modern and demanded products to the world market. The company activities pursue the principles of environment preservation for future generations. Responsible attitude to environment protection, ensuring of nuclear radiation, environmental and general industry safety are the most important prerequisites for production and operation activities of the Rosatom State Corporation. Nuclear Technologies Engineering Services is a division of Rosatom. Nuclear is globally active in the areas of radioactive waste management, as well as decommissioning of nuclear facilities and engineering. Nuclear uses advanced approach to transfer naturally occurring radioactive waste into a chemically stable state by means of appropriate conditioning and thus safely isolated from the environment. So today, Mr. Klaus Büttner will be sharing with us detailed information on the technological offer in the field of norm waste management. I'd like to introduce you now to our presenter, Mr. Klaus Büttner. He's the Chief Technology Officer at Nuclear Technologies Engineering Services. His experience in hazardous and radioactive waste management lasts back more than 25 years, gained in many international projects around the globe. Joining Nuclear in 2003, he is leading the technological department since 2017, responsible for Nuclear's R&D work and supporting cells with technological background. A major target of his work is the development of new products in the field of norm management. I hand you now over to Mr. Büttner.
Okay. So, will you see my screen now?
Yes, please just put it in presentation mode. There we go, thank you.
Okay. So let me just. Okay, so thank you for the kind introduction. My name is Klaus Büttner, as mentioned, and today I will talk about norm management, norm waste management, a chance for further waste minimization. The presentation will be structured. I shortly will say some words about my company, Nuclear Technologies Engineering Services, then reflect on what is norm waste anyhow, where it's coming from, what are the norm waste management doing, or what are the elements of norm waste management, give an example for norm pipe cleaning, which we offer to the market, and also the treatment of the resulting residues from such cleaning technologies, and then of course a conclusion. A little bit history of Nuchem. Nuchem itself was founded in the 60s, so we have 61 years anniversary this year. In the beginning, it was built for fuel element production. So we did a lot of research in form of for the nuclear industry, how to produce nuclear fuel and so on, but also then concentrated here later on the management of radioactive waste coming from the fuel cycle, and later on also from reactors and other entities of the fuel cycle. In 2013, Nuchem Technologies Engineering Services was founded to cut out a little bit the engineering service in order to provide this to the clients worldwide. I will come a little bit to the history in the next slide. And today we are roughly 130 employees and have a backlog of 150 million euro. And we are 100% subsidiary of Rosatom. Here on the, let's say, timeline, you can see that we are founded in the 60s, but in 2006, I was already here. We were sold by the utility RWE, which wanted to get rid of their nuclear business at that time due to the German policy, sold us to an American investor called Advent, and this later on sold us 2009 to the Rosatom Group. First, we were part of the ASE, which is the utility or the builder of the constructor of new nuclear power plants, and waste management is part of that. Now we are transferred to TWEL, which is the fuel element production company of Rosatom. And this is a little bit for us coming back to the roots. As I said, we were founded to produce fuel elements. And so we are in the moment doing this here together with TWEL. What is our normal work? Of course, we are a German entity, so decommissioning of nuclear facilities is one of our major tasks in the moment. We have different projects running in Europe for dismantling, and there we are concentrating on the nuclear island, meaning the pressure reactor vessel, the reactor pressure vessel, the internals, as well as part of the steam generators and so on. Another point is spent fuel management, where we are building buildings for the facilities for the spent fuel cars to store. And let's say one of the largest part is management of radioactive and hazardous wastes. You see here in the small picture above the management that we have a monitoring station, for instance, for free release material, where we process and monitor large amounts of soil for their content of radioactivity. The limit is 1 becquerel per gram, and we have to measure that. And we are doing also engineering, consulting, and other things. And during these engineering and consulting activities, I was for a few years involved in a South African project. So I was often in your country, which was quite lovely, dealing with the pebble bed modular reactor program. And we were responsible to design the fuel plant, which we had the knowledge from the past. But coming to waste management in total, there are all different management technologies in our portfolio you can think of. If it's thermal treatment of wastes, is it a chemical treatment of waste, solidification, filtration, drying, pre-treatment, and so on. And so we try to modify all these technologies fit for purpose for the different needs of the client. And one part of that is, of course, also the norm treatment. And this is every time equipped also with the ECNI, so we bring with our own programming and so on with us. Regarding waste management or norm waste, I can recommend to read this Management of Norm Residues from the IAEA. It's a really interesting and viable document for getting some deeper knowledge of the norm itself. And you see on the left-hand picture that the norm waste is differing between that you have so low levels that it's nearly clearance or exemption level waste, but you can also go as high as lower intermediate levels for waste. And of course, then you have to handle it according to the radioactive waste standards. Where is the norm waste coming from? You see it's a wide mixture here from different mining processes, different ores to be extracted and so on. But also the production from oil and gas is one of the key areas where you find norm waste in the piping, in the elements, and so on. So where is this norm especially coming from? You see here on the right hand a picture where you see from the drilling you get all these radionuclides mobilized from the underground, and they will then deposit on the surface, the inner surface, for instance, of your piping, but it will also be dragged into the equipment or into your tanks. You see also the activities may not be too high. As I said, limitation normally for clearance is 1 becquerel per gram. So we are here in a range of 20 times or only twice the amount which is allowed, but you have to deal with it. And during the process, you may also concentrate this specific activity to higher levels. And of course, the level of radioactivity also depends a little bit on the circumstances. So you have to see on the specific case what amount of radioactivity you have to deal with. So norm waste management. We in NUCAM, we try to think it a little bit from the back side. So the waste package must comply with the disposal facility. So there is the rule, no waste without any outlet, no waste route. So you need to know where to bring your waste and what are the waste acceptance criteria there. If this is unclear, normally the waste form needs to be solid, non-dispersible, so it doesn't leach too much, and passive from a chemical point of view. And then you are normally entitled or allowed to bring it to landfill sites or engineered near surface or surface repositories, depending on the actual level of your radioactivity in the waste form. So if you want to select proper treatment, then you need to define or to know, if this is available, the waste acceptance criteria of your final storage or disposal site. So normally we start by a so-called pre-treatment or upfront treatment. So you need to collect the norm waste from its place of origin. You can try to segregate by physical or chemical means. This means if you have a pipe or a valve or some other equipment, you try to segregate these by the type of equipment, but also maybe by the type of material used, like stainless steel, reinforced plastic, or carbon steel, or whatever you have as material inside your facility. And then you need to remove the contamination by surface decontamination. This is depending where the contamination is, mostly inside, so you need to clean inside with special means. Typically, this is by high pressure water jet processes. They are used really worldwide in this area. But you end up, of course, with a sludge or a slurry, the mixture of your norm containing the solid material and the water. So the next aim is to reduce the volume further in order to separate the water from the solid part. This can be done by filtration. If you want to go to higher levels, you can use evaporation. If you only have specific radionuclides, you can also use ion exchange systems in order to transfer your radionuclides to the ion exchange material and then treat the ion exchange material, and the rest, your sludge and the water, is free of contamination. You can then treat it as normal wastewater or sludge. You can also, in order to support these treatment steps, change the composition like precipitation, flocculation, in order to make the, let's say, separation better. And a last step then in norm waste management would be the conditioning in order to come then to a waste form which complies with your waste acceptance criteria, so is suitable for long-term storage, transportation and handling. And there are two main treatment technologies. One is drying, so you after dewatering, you try to get out all remaining humidity out of your system and then store it for a long term. Or you immobilize it by solidification, meaning that you use cement matrices or others to stabilize inside of a waste package your waste. Or if you can just pour a cement low viscosity cement matrix over it and fill the voids, this is then meant by grouting. So it's not mixing it, it's just overflowing with cement matrix. A little bit just to show that there are different possibilities to dispose of your norm waste, and this is why you need to select your technology based on where to bring it later on. And of course, you see here there is a lot of different possibilities, but with the level of contamination or concentration of the radionuclides, you need to go to the right-hand side, and you see that then it's the degree of isolation from the public which is the driving force here. I think nowadays what is on the very left-hand side, just put it on the surface or let it dilute into the surface, will not be done practically anymore, because you will have then sites you have to clean up maybe in 10 to 20 years again. So norm waste management starts, as I said, with the norm survey at the operational site. So you are going there, doing monitoring by radiation measurement. Here you have to see that due to the fact that we have a lot of alpha emitters here, it's not so easy to measure the radioactivity. So you need to see if it's possible from the outside. But sometimes or often you have to go dismantle the pipe or the equipment and then measure from the inside your contamination. Of course, you need also to take care about the personal exposure to the norm waste. This is also one of the driving forces in the industry, not to get too high dose rates to your personal. And you can do these surveys also during maintenance activities. when you already shut down a plant and have the ability to get inside of tanks or dismantle parts in order to measure inside. Once you know what the contamination is and where you have to clean or to remove parts due to the non-contamination, you can start the decontamination process. This is normally done on-site for larger pieces like vessels and tanks. For the piping, it's in the moment more or less off-site, and you transport the pipes to the treatment area. I will show you an example where we try to make this in an on-site environment. And of course, you can decontaminate smaller equipment like valves and so on, also in an off-site facility. But this means you have to transport the known contaminated equipment and later the decontaminated materials again. So you have a lot of transports of radioactive material and later maybe a free release material. And the last step, as I explained, is further volume reduction of non-contaminated soil and sludge you are getting from the decontamination process itself. Is this ping something I need to consider? Are there questions in between, or shall I just continue? I guess that's a continue. Huh? Pardon?
Please continue.
Okay. Okay, just to visualize maybe what I have said just is you see maybe this is working. Yeah, you see we have the site. Yeah, you have your norm survey, and then you know the tanks, the pipes, the parts and equipment. And if you do the normal way, the tanks are cleaned on site. You will have clean tanks and norm the residues you have to treat. And only, let's say, the dewatered sludge or something like this, you will transport to an immobilization facility. Pipes normally are transported to a centralized descaling or decontamination facility, for instance, where also the parts and other equipment are transported to. You will have the clean pipes and parts, which are then removed either to the site for direct reuse, or you will find a recycling way where, like a metal melter or something like this, using that equipment if you do not want to install it again in your facility. And you need, of course, a norm residue treatment, and you are bringing this to immobilization. Maybe this is on the same site. What we propose is also that the pipes are descaled on-site, norm treatment, and then only transport the smaller fraction of the norm residues to the immobilization facility. So avoiding a lot of transports here and backwards to the site by just transporting the residues which are produced during your process. A few words about monitoring. You have different surveys you are normally undergoing. You have baseline service. Frequently, you are looking at different areas where you know that you have a compilation or a concentration of norm radionuclides in your processes. You can do this when you know you have a regular shutdown. You may do this upfront in order to see if you want to dismantle things and separate pipes or exchange pipes during that service. Then you can do it during operation, assessing if you find that there are some, let's say, measurements going higher than expected during the time. And of course, if you have a legacy site where you stored a lot of old pipes or valves or other equipment from such processes from the past, you can use monitoring in order to see which part excuse me, which part of that legacy waste you need to treat. And you see there are radiation detector types which are available for alpha, beta, and gamma. As the norm radionuclides are mostly alpha emitters, I think you have to see that you have to measure directly at the surface of the contamination, which means inside the tanks, inside of piping, which is sometimes not so easy. Luckily, or it depends on the view, from a monitoring point of view, you see on the right-hand picture that there are also small levels of dose you can measure in the different areas. And so you're also able to measure from outside and then later on do, let's say, a more detailed monitoring when the equipment is already dismantled. Coming to typical scale treatment, scale is the deposit inside of the piping. I had a source where it stated that it's around 100 tons of pure scale per year for one oil well in the USA. It was not mentioned how long this oil well would be, but I think it's a certain amount of deposits you see here. And you see also in the table that they have a quite wide range of activity concentration. You see here a maximum of 15,000 becquerel, so you are far beyond any release limits. And also what to do with these scales, there are possibilities to mechanically remove it by a kind of boring the inside of the pipe. Or you use chemicals in order to resolve the deposits by chemicals, but then you have, of course, also to treat these chemicals again in order to be environmental friendly. You use abrasive technologies. This could be dry technologies like sandblasting or something like this, or you use high pressure water jetting, which is, from our point of view in the moment, the, let's say, mostly used technology, the water jetting. Or what you also can do for complex structures or something like this, where decontamination is hard to undertake, you can melt the whole component, the whole equipment, and the scale and the radionuclides will then go into the slag, which you can remove from the metal, and the metal can then go to recycling facilities. So what are we doing? When we are looking to pipe cleaning, you see here a picture from us in the 2004, year 2004, manual cleaning outside and inside of pipes, which was quite a lot of work. And you see the people have to work in complete personal protection equipment, with air supply and so on. So there are a few certain design challenges here. Yeah, we have the personal protection, the health physics. You need a controlled area to do this, because by using these abrasive or high water pressure jetting, you have a lot of spread of material inside of such an area you need to keep. You need a ventilation suitable for your system, and you need the filtering, recycling of the water in order not to produce too much secondary waste. So we decided that you can do this in a centralized facility, but then you have to transport all the material back and forth. So we designed together with a partner a mobile pipe cleaning system. And we see as an advantage that you have, of course, reduced transportation, which is a cost factor for the client, but also is smarter for the environment. with the discussion we have in the moment. You are reducing working time because it's a more automated system, not too much manual handling, and therefore you reduce also the risk of getting in contact with the norm waste and the radionuclides in it. We see it's relatively quick and easy on site, so no big time issues here. You have reduced storage costs here because you do not need a buffer storage before you transport to your decentralized to your centralized treatment area. You do not need any buffer area at that centralized area before treatment. So this reduces also costs. And of course, we are offering here a full service. We do the transport assembly to the site, we do the cleaning, and later on then the disassembly and so on. So in the end, you will have some clean piping and a waste package, a waste form, which is suitable for long-term storage. How will this look like? So you see here the proposed solution. We have 3 containers. The first container is the most important. You have here the high pressure pipe, which is attached to the cleaning device inside, which is moving by the water pressure through the scaling to the end of the piping. Due to the water spraying, air will be sucked from the right side and will go out to the left. The water itself with the scale, with the removed scale, is then collected in this tank and then cleaned by dewatering means and so on. And we have, of course, some fine filtration later on in order then to have proper, clean, reusable water which can go in the circle then in order to minimize the water consumption. The pipe itself is connected between one of the containers and the other and surrounded by a protecting tube in order not to spread any contamination. On that container, we have then also the monitoring part. So after cleaning and removing of the cleaning device, the pipe will be pushed through these monitors in order to see that all the contamination is removed. A 3D model of that system, you see the 2 containers. We have a construction in order then to have a reliable movement of the pipes. The pipes are coming by forklift trucks, for instance, depending on the length. And here is then the end on the measurement of the system. This same picture a little bit cut open. You see here again the high pressure water jetting and the hose rolled off, and then you have the length of pipe you need to provide flexible hose in order to go through all that. And in this container you have the cleaning devices. So what we are using here, or what we designed it for, you have diameters from 100 to 400 or 4-inch to 15-inch, depending on your scale. In principle, we designed this together with a company doing sewage pipe cleaning. So they are used to do 50 meters and more of pipe cleaning. But we see, due to the handling of the pipe itself, that 12 meters may be the limit, depending on the possibilities we have on site. You can bend, so you can also go through corners up to 90 degrees C, but of course this will reduce the speed of cleaning and depends on the diameter. Higher diameters are also higher bending possible. And there are a lot of different spray nozzles, you see it available. As I explained, the principle of cleaning is that this is getting into the pipe. These high water sprays will remove the deposit from the inner surface and flush it out to the sludge water tank. And by that high pressure, this will move automatically by itself through the pipe. So you do not need to push it. It will suck itself through the piping. The same you can do for a little bit smaller diameters, or if you have very big incrustations, big scaling in it, the length is the same. What here is differently is you have this mechanical driller or removing mechanically the deposit, and then you have for the remaining on the surface, in order to get a real clean surface, you have then the high water spray nozzles. So what to do with the resulting water sludge mixture? As I said, we have a dewatering already included in the system, but of course this will have 50% water in it or whatever, maybe even a little bit higher, so it's just a sludge. So Nukem is also offering drying systems. For instance, you see here drying chambers where you can place 4 drums. They have lids, so all the vapors are collected and then condensed. The condenser is the same on both sides. You can see it here. Here's jacket heating drums. So the heating jacket is around, so have a better heat transfer. And this, if you do it with the chamber or with the heat jacket, depends a little bit on how far the first dewatering step can be done. So here you have higher water contents with the jacket heating, because here you can get more heat in. If you only have wet sludge here, maybe this is then sufficient. And we are also looking how to make it even more friendly, environmentally friendly, in order to see if we can do, for instance, the heating itself by solar energy or something like this, looking to be more autark in our site, so that we do not have to bring too much energy from outside or with the facility to the site. If drying is not suitable for the long-term storage, depending on the waste form and later on the waste acceptance criteria, you can also use immobilization. Here, as an example, a grouting facility where you just produce the cement matrix, which is then of a low viscosity so that it's filling all voids, and then you pump it directly over your remains. So there is no mixture, it's just filling up your waste package, a 200-liter drum, for instance, in order to immobilize your norm waste. We do this in the field of nuclear waste very often for waste packages having heterogeneous material in it, like pellets from the high force compaction, or metal waste which is there, or bulk material you need to immobilize. The other thing is, if you want to embed the norm waste residues in the matrix, you use, for instance, an Indrum mixer here shown in this picture. We are using this, for instance, for evaporator concentrates, ion exchange resins, in order to have then a homogeneous mixture inside the waste package. An example for such an Indrum mixer is seen here. So it's not a very big component. You have the mixer itself, you bring in the drum with the cement, the dry cement, and then you fill via some tanks the sludge or the material inside of the drum, for instance, and then with the mixer you go down, mix it, homogenize, go up with the mixer, clean the mixer, and then you can remove the drum. Okay, to summarize, So where do we do waste minimization here? So as I said, the target itself is that we have a waste form which is suitable for long-term storage or final disposal. So the first minimization step is that you do your norm survey on site in order to find out what of the material is in need of a norm treatment. Maybe not all of it is norm contaminated, maybe something is only encrusted by different means. If you have separated this, then you do the destaling, the surface decontamination inside, for instance, by the high water pressure jet processes. And then you have the next minimization step, because now you have your clean equipment, the tank, the pipe, the valve or whatever, and the remains, which is a huge difference in mass and in volume. And you are avoid also, if you do it on site, a large number of transport of norm material. So this is the benefit we see from such on-site processes. And later on, when you do the dewatering or filtration, ion exchanging, and so on, then you do the next step in minimization of your volume of your waste, because you get the clean water out of your material and only have to dispose of the solid fraction of your system. And later on, if you do the final conditioning, if you are allowed to dry and then use the waste form like the drum or concrete container as the barrier for your disposal site, then you even further reduce the waste, because immobilization by solidification and grouting will result principally in a volume increase again. But nevertheless, even with immobilization, the resulting volume of your norm waste will be far less than if you do nothing at all. So, thank you.
Thank you very much for that, Klaus. I appreciate that. Any questions from our attendees? I have no questions at the moment, but a question from myself is, how does Nucom Technologies fit into South Africa? Do you also supply to South Africa, or is it through Rosatom?
We use the network of Rosatom for the worldwide sales process. Nevertheless, you can approach us also directly if you have the need, because we are having own sales activities worldwide, in South Africa, in China, you name it. And if we know what to do, we will involve Rosatom anyhow. So both sides, both ways are possible. We are currently working together with their their network, which helps us also as a small company to have the benefits of the larger Rosatom group.
I see, that's excellent. I'm also the managing editor for the What Now magazine that the SAIEE produces. And I would like to get some information from you for an article for a future issue. And I'll definitely be clicking on your button to get us more information that can go worldwide. We have no questions from our attendees. But if you have any questions, you're welcome to email me, minx@saiee.org.za, which I will then forward to our presenter, Mr. Klaus Buttner. And also, if you are interested in joining the SAIEE corporate partnership, you also can send me an email at the same email address, and I'll send you more information. Well, then this concludes today's webinar. Mr. Buttner, thank you very much for availing your time for sharing the information to our attendees and us as the Institute. I hope to see you soon again. It was lovely to meet you, and I thank you all our attendees for attending our webinar today. Have a good day. Thank you.
Thank you. Also from my side, a pleasure. I hope the questions will come when it's sucked in a little bit more. So hope to be in South Africa at some time again, because I love that place, and thank you for the opportunity to speak here.
Excellent. Thank you, sir. You're welcome. Have a good day further. Take care.
Thank you. Bye.
Bye.